I'm just going to go ahead and write it in the form without the exponents. Okay, so I'm going to write it down as 4y minus 1 in the numerator over 2y minus 5. And then that's plus 5 2y plus 3 plus 5 2y plus 3 in the numerator. And then 5 minus 2y in the denominator. And then y minus 4 in the numerator. And then 2y minus 5 in the denominator. So I've skipped actually writing the question as written and just jumped to the chase because each one of these was given as something to the -1 power. And all I did was say, well, something written to the -1 power just means that it's in the denominator raised to the first power. Mm-hmm. Okay, and now I'm thinking, okay, it says perform the operations and simplify, and everything that we've been doing in this section has been, we find a common denominator, and then we just add everything together. Once we get a common denominator, then we can move on. And what I see right now is those two terms are the same, but that term is not. And I also noticed that if I could just flip that, then I would have the same denominator. And so we talked about this in class. I'm going to copy down the stuff I'm not changing first. So I'm not going to change the first one because it has a denominator that I want. I'm not going to change the last one because it has a denominator that I want. And it's like that. And so with this guy, I'm just going to flip him. And then what do I write on the outside of that? Big fat negative. Remember that?
And then you bring it up so it's not negative.
And then I'm going to bring it up. I'm going to say, exactly. I'm going to say, well, that's a negative number. That's a plus. So it's the same thing as just flipping it and making that guy a minus between there.
Okay.
Okay. Then I'm going to say, aha, common denominator. So I could write all of this with one common denominator, which is 2y minus 5. Then what I'm going to go ahead and do this in a couple steps here. I'm going to go ahead and distribute this 4 in, because as I see it, I'm imagining, well, that is my numerator right there, and I'm not seeing anything I could do with that. There's not a common factor in each one of those, and so I'm just going to go ahead and multiply everything out, and maybe I'll be able to rearrange and maybe factor some stuff out. I don't know, but my first thing I want to do is multiply everything out. So I'm going to go ahead and do that. So instead of writing all of this over one denominator, right? I mean, all of this stuff in the numerator, I'm going to do 2 steps at once and say, okay, this 4 jumps over and I get 4y. The 4 jumps over and gives me a -4. I'm going to think about this as a -5. That -5 jumps over and gives me a -10y. The -5 jumps over and gives me a -15. That's a plus, so I don't need to worry about it. And that's just a y minus 4. There's nothing to do, so plus y minus 4. Now I'm going to, I guess I'll get all my y's together. I'm still with this denominator, 2y minus 5. And let's see, how many y's do I have? I'm seeing positive y's here. So there's 4 plus 1 more is 5. So 5 y's minus 10 y's is a total of -5 y's. So -5 y. And I do like to do this. If you were to look at my any scratch work that I do as I'm working a problem out, I will circle like as I go along, just like I was saying. And then once I've written it over here, I'm going to go ahead and just cross through them. So I know, okay, I've already counted those. We're good to go. Now we have a -15 and a -4 for a -19, minus another 4. and that should give me minus 23.
Uh-huh.
Yeah, minus 23. So minus 23 right there. And now I'm seeing there's nothing I could pull out anywhere, right? That is just, yeah, because 23, I believe, is prime. It's certainly not a multiple of 5. So maybe, I mean, if I wanted to, I could pull out the negative and call it 5y plus 23. Although, depending on the context of the problem, I may or may not want to do that. Either one of these is a perfectly good answer. What is that one in the back of the book? Is that what it says? Let's check. This is section 6.2.
6, 2, yeah.
So 6.2,
Well,
number 35. Yeah, okay. So this is what they're doing. So here we go. Like I said, this is a perfectly good answer. I feel good about it. But I go to check it in the back of the book and, oh, that's not the right thing. But what I notice is what they've done is they've just taken this negative and put it down here. They've taken like an extra step. And for whatever reason, who knows why, they said, you know what, we could bring this negative down here, basically, and say, okay, now we're going to distribute the negative in, or we could do that same kind of trick, right? It's a negative 2y and a plus 5, or in other words, just flip it like that. And that's what they've done. 5y plus 23. And it's exactly equal. This is exactly equal to that, which is exactly equal to that. And that's all they've done. They just chose to write it. They chose to write it. They chose to write it
right.
this way for whatever reason they did, whatever.
Okay.
But that's it. So any one of these is fine. Any way you want to write that. But what's nice to know is sometimes you'll end up with an answer like this. And then you go to check your answer and you're like, oh man, I must have done something really messed up because I didn't get this at all. I got this. And then at this point, and pretty much for the rest of your time that you're in math, this is going to happen. And you could easily go, oh man, I don't know what's going on. Well, hold up. Maybe they chose to write it a different way. And maybe we can manipulate this a little bit until we get to that, which in this case, we can.
Mm-hmm.
So, okay. Are we good with 35?
Yes.
Okay. And then did you want to talk about 43 or did you attempt 43?
I did not attempt 43 because I thought it was 40. So I did not.
I want you to do 43. Let's go ahead. We'll tack that on for tonight, for tonight's homework.
Okay.
Now, we should not be meeting next week. Next week is Christmas, right?
Is it?
I think so. What day is today? Today is the 15th. Let me look at my calendar. Today is the 15th. That means that next week is the week of Nativity. So we are not meeting next week. And
okay.
If you want, you want to take another week off, we could do 2 weeks off.
All of my schools give me 2 weeks off. Also, I'm going to be out of town through the 31st, from the 31st through the 6th. So
6th.
What's wrong?
Okay. Then let me look.
I don't think I usually have next week off for my school. They always give me, it's kind of weird. They don't give me the week before Christmas off. They give me the weekend before Christmas off and then 2 weeks after.
I think that's how it is in college too. Or well,
okay.
It depends. It flips back and forth sometimes. It depends what day of the week Christmas falls on. But sometimes you go pretty close. So let's do a couple of days. Let's do Wednesday or Monday, Wednesday next week.
That's usually what I have.
Okay, great. Then we'll keep with that.
Okay.
You said that this weekend you are doing a thing, right?
I am.
Okay.
I think my mom was going to talk to you about it because we're planning on going on a family adventure on Friday. And then I have to leave for the weekend.
Okay.
So I'm not entirely sure what Friday's going to look like.
Well, what I wanted to say, I've decided this weekend, there's no homework this weekend. I'm not going to do any assignments. What we're going to do on Friday is we're going to work. There are some skills that we're really going to need to have for the upcoming stuff when we start talking about quadratic equations, which will be a huge focus for everything.
Okay.
In fact, it's amazing how often quadratic equations show up in mathematics, and not just like contrived examples where you know that you're going to have a quadratic. They show up everywhere. It's really important to be able to deal with them and manipulate them. And so with that in mind, before we even get there, I want to do a few like drills, basically, go over a bunch of examples and stuff. And I'd like to do that like one-on-one where we're both doing it. So what I have in mind for Friday is we're going to basically spend the whole time. I'm going to put a problem on the board, and then you do it, like you just scratch it out, and then I'm going to do it. And we're just going to keep doing that. And the problems I have are going to, trust me, we want to be able to do these in our sleep. And so that's going to be the point of what we do on Friday, is so that we're going to get to a point where there's basically two things. There's two things that we need to be able to do in our sleep in order so that when we get into quadratic equations, we don't need to worry. It'll be like second nature to us. So does that sound good? Does that sound like a plan for Friday?
Yes.
Cool. And then no homework because it's Christmas, man.
Okay.
And you're doing.
I will have my mom talk to you about Friday.
Okay. And if we don't meet Friday, that's cool too.
Okay.
The whole point is I do not want to get into the next thing, which is 6.3. Oh no, I'm sorry. That's what we're doing today. Then I don't want to get into 6.4, the division of polynomials, unless you're going to have consecutive days to work on stuff. And so I think we'll do some drills on Friday, if we meet Friday or whatever. If not, we'll do that another time. That's fine. So without further ado, are we ready to start on 6.3?
Yes.
Okay. So here's the big idea with 6.3. 6.3 is where we are given stuff like this. We are given fractions inside of fractions. And like everything in mathematics, right? We're taking something we haven't seen before, and we want to turn it into a problem that we've seen before. And so what we're trying to do is turn things that look like this into things that look like this. And in general, what these things are going to be are polynomials, right? We're going to have like x plus 1 down here and 2y minus 5 right here. And what we want to do is manipulate this. Excuse me. We want to manipulate this thing so that we just have one polynomial on the top, one polynomial on the bottom. Because in case you haven't been paying attention, that's what we've been working on, right? Like fractions of polynomials. And now we have some kind of idea of how to work with fractions of polynomials. But when you have fractions of polynomials, it's like, uh-oh, what do we do with that? Well, what we do is we turn a problem we haven't seen before into a problem that we've seen before and work from there. And so that's what we're going to be focusing on today, is how do we take an expression like this and turn it into something like this? So what I want to do, just same like what I like to do with everything, is we're going to, before we jump into using polynomials, let's just see what we would do with numbers. And so I'm going to write something down right here. And I think the one I decided on was this: a half plus, I wanted a quarter, and then a third, and then a 12th. Now, if we had something like this, and you're thinking about what we did in the last section, you might be thinking, aha, we're going to have to get a common denominator here, add these together and we'll have a fraction up here. Then I'll get a common denominator here, add those together and I'll have a fraction down here. Then I'll have a fraction divided by a fraction. And so then I can multiply by the reciprocal of the bottom, and then I'll have my expression. And we could do that, but there's a much easier way when it comes to having fractions inside of fractions. So for right now, what I'm going to do, I'm going to illustrate that way, that idea, getting a common denominator and everything. But I don't right now, do not write anything down. Don't write any of this down, because this, what I'm about to do, is not what we're going to do. And I don't want to have any kind of confusion here. Like I'll just say it again. What I'm about to do here is not the method that we want to use. But I do want to do it to just show you that what we're going to do will be consistent with everything else. So this is the method we're not going to do, which is find a common denominator. And on the top, so first off, I got that big fraction right there. And I could think, okay, I can get a common denominator if that guy's a 4. In order to turn that guy into a 4, I need to multiply it by 1. And the way I'm going to write 1 is 2 over 2, right? And then I have 1 over 4. Yeah. And I'm just going to go ahead and do that and say, okay, 2 times 1 is 2. 2 times 2 is 4. And now I have 2 quarters plus a quarter on the top. Okay. Here in the bottom, I'm seeing, okay, how could I get a common denominator? Well, one way would be to take that 3 and multiply it by a 4. And so if I have this 1/3 and I multiplied that 3 by a 4, I would have a 12. But I can't just do that willy-nilly without changing the fraction. So I got to do it on the top as well, right? And so then I say, okay, the 12 is going to stay there. The 1 and the 4 make a 4. The 3 and the 4 make a 12 like I wanted. And now I have that. Okay. Now, I mean, I could put these under a common denominator. Or I could say, well, you have 2 quarters plus 1 quarter. You have 2 apples plus 1 apple. You have a total of 3 apples. This is just 3 quarters. And then down here, you have 4 twelfths plus 1 12th is a total of 5 twelfths. And so then we're going to do our flippy thing because we have a fraction divided by a fraction. So we take the numerator and multiply by the reciprocal of the denominator. So that's 3 quarters times 12 fifths. Which if we reduce this out, we have 3 times 4 times 3, right? 12 is 4 times 3 over 4 times 5. And so the 4's cancel. And I have 3 times 3 is 9 over 5. So altogether, that gives me 9 fifths. And if you like, you could do that a couple different ways. But okay, so that would be the, I don't want to call it a naive way, but that's the kind of the obvious way of doing what, that would be the obvious next step in what we're doing. If you were to just give me this and I didn't think about it, I'd say, well, I know how, I mean, we've just been adding these types of things together. So let's do that. And then we get this and we get 9 fifths. But in practice, this is much harder than what we're going to do. And the way we're going to deal with this, again, I'm going to do something else here. This is kind of almost the way we're going to be doing this. I don't want you to write this down because, again, this is not what we're going to do, but it's much closer to what we're going to do. Another way we could treat this is to say, well, and this is what I think whenever I see this, I think, okay, I know how to divide things, but when I have fractions inside of fractions, my mind kind of gets a little crazy. I don't know how to deal with that. And so I'm going to turn a problem I haven't seen before into a problem I've seen before. In other words, what I want to do is kill each one of these fractions. I would like to kill these denominators. And what principle I'm going to use is like, if I wanted to simply kill that denominator, I would have to multiply by, well, whatever's in the denominator. If I wanted to cancel it out, I would multiply by whatever it is. If that thing down there was a 3, I would say, well, the thing that kills that denominator is a 3. If it were a 7, I'd multiply by a 7 and so on and so forth. And so what I just kind of do is say, well, the cool thing about this, and this is key here, is that you have fractions and inside of a bigger fraction. And so we could play this kind of game where we say, well, wait a second. If I wanted to kill that 2, I could just multiply it by 2. In fact, I'm going to go ahead and give myself some room here and say, okay, if I wanted to kill that 2, I could just multiply it by 2. But of course, I don't want to change the overall fraction, so I have to also do the same thing to the denominator, which, that's exactly what I did right here, right? I said, I still want this thing to equal 1/3, but I want to write it in a different way, right? Which is 4/12, right? So that's kind of what I'm doing. It's like, I have this overall fraction that I don't want to change. And so whatever I do to the top, I got to do to the bottom. And then I could say, okay, I want to kill that guy right there. I'm going to need to multiply by a 4. Whatever I do to the top, I got to do to the bottom. Okay, so that will definitely, and remember, like this is what we got to keep in mind here is I have a sum that I'm multiplying by a number. This number is going to distribute into each one of those, right? Just kind of keeping that in mind. Like this is the game we're playing now. We're going to write down a number that's going to distribute into each one of those. This, whatever I write down, is going to distribute into each one of those. Okay, well, now, if this distributes into there, those 2 denominators are gone. And I will just have a plain old whole number and I'll be good. But down here, not so much, right? So naively, I could just keep doing the same thing and say, well, there's a 3 right there. I want to kill that 3 when this number jumps over here. And so I need a 3 down here. Okay. But if I put a 3 here, I got to put a 3 here. So I'm going to have to do this right there. And then finally, I could say, okay, I need to kill that 12. And so in order to kill a 12, I'm going to have to multiply by 12. We could do this. And this would work. The thing is, it's kind of overkill, right? Like you could kind of see what's happening, and you might have noticed you'd already written 4 times 3 right there. That 4 times 3 is 12, and that thing would kill this. But we'll get there in just a second. So now, if I did this, which again, I hope you're not writing any of this down because this is not exactly what we're doing. It's very close to what we're doing. It's more to the point, but this is overkill. And we're not going to simply say, well, we'll just take every denominator and just multiply by every denominator. I do want to go through this because if you're completely lost and you just happen to do something like this and you just go, you know what, I'm gonna kill, it's called like using a cannonball to kill a housefly, right? Like, and you just go way above and beyond and you do this, it'll still work. It's just you're going to have a lot of extra work to do. And so what would happen is this number, this whole thing in those parentheses, I could figure it out. I could go 2 times 4 is 8, times 3 is what, 24 or something, times 12 is whatever that is. But it's already nice and factored, and I'm going to keep it like that and say, okay, well, then this thing distributes over into each of these, giving me whatever that number is, 2 times 4 times 3 times 12 over 2, plus 2 times 4 times 3 times 12, 2 times 4 times 3 times 12, all over 4. Oh boy. Same thing down here. Okay, this guy jumps over and hits that guy right there. And we have 2 times 4 times 3 times 12 all over 3. Finally, 2 times 4 times 3 times 12 all over 12. And now I could do my canceling. The 2 here cancels with that 2. The 4 cancels with that 4. The 3 cancels with that 3. The 12 cancels with that 12. And we're left with this is still really ugly. And it's like, this doesn't seem to help me very much. But I'm not going to go any further with this. But I will note that I did this earlier and calculated it out. And it does indeed, when you do the final multiplications, and addition, and then the final division. If you were to figure this out, which is, what do we have? 4 times 3 times 12 is something big. 2 times 3 times 12 is like 72. Add those things together, blah, 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 blah. It does reduce down to 9/5. And so what I'm getting at, and what we'll see in a minute, like when we're actually using polynomials, sometimes you go a little bit above and beyond and you add a few more terms than you strictly need. And that's fine. It will all work out in the end. It's just that, well, we didn't need all of those numbers to kill every one of those fractions. And now I'm going to ask you to start writing stuff down, because this is the idea of what we're doing. Given an expression like this, 1/2 plus 1/4, all over 1/3 plus 1/12. My goal is to multiply this thing through by something that will kill every one of those denominators. And I don't want to change the fraction, right? So I am going to do this type of thing. I'm going to say, well, the same way as here, right? If I multiply by some number over itself, it doesn't change the fraction. So I'm going to do that. I want to multiply by some number. What number would kill every one of those fractions?
Only one number?
Yeah. Well, I mean, well, we could factor it out, but there is a number that's actually, it's one of the denominators. One of those denominators would actually do it. Does 2 do it?
No.
4?
No.
What is it?
Is it 12?
12. And this is, I don't want you to think like you should be able to intuit this. That's not, and you'll see when we start working these out, we won't need to do that. Because in fact, what I could have done is said, well, I'm going to need a 2. And so I write a 2 here. And so I write a 2 here. And then say, well, what about that guy? He's not going to get killed by a 2. He needs an additional 2. He's going to need a 2 times 2. Okay, so I need a 2 and times a 2 right there. Make my parentheses a little bit bigger. And then it's like, well, the 2 and the 2, that's just a 4. If he jumps over, well, 4 over 3, that doesn't cancel. He's not going to cancel the 3. We're going to need a 3 right there. And so I'm going to put in an additional 3 right here. Whatever I do to the bottom, I got to do to the top. And then I go here and say, well, what about that 12? Oh, wait a second. 2 times 2 times 3 is 12. And so we could have, in the way that we're going to do this when we do polynomials, that's the way we're going to think about it. We're just going to start looking at denominators and saying, well, in order to kill x minus 1, we need an x minus 1. In order to kill this, we're going to need that. And we just start stacking them together. But we don't want to go overboard like we do in this case. It's like, yeah, 2 will kill that. 4 will kill that. But we don't need to write 2 times 4. That's way overboard. We just need a 2 and a 2 in that case. Yeah, buddy. And so on and so forth. Does that reasoning make sense? Kind of how I came up with this 2 times 2 times 3?
Mm-hmm.
So that, and that's what I was getting at, is like, what one number would work? Well, that happens to be 12. But anyway, so now that we have this, and I'm just going to keep it like this. I'm not going to write it as 12 because, well, yeah, buddy. polynomial. So now let's go ahead and distribute this, right? This number, 12, written in a way that helps me out, 12 jumps over and hits the 1/2. And we get 2 times 2 times 3 all over 2. This number jumps over and hits the 1/4 to give me 2 times 2 times 3 all over 4. This number jumps over to give me 2 times 2 times 3 all over 3. Plus, and then that jumps over to give me 2 times 2 times 3 all over 12. Now we can do our cancellations here. The 2's in the first cancel. This 2 times 2 is 4. And so both of those cancel out that 1, 4. This 3 cancels that 1, 3. And that entire thing is 12. So that cancels the denominator, leaving me, let's see. Right here, that's a 2 times 3. So that's a 6. Plus just a 3, just by himself, a 3. Okay. Those 3's are gone, and in the numerator we have a 2 times 2, which is just a 4. That was the same thing as 12 divided by 12. That's just 1. And we end up getting a 6 plus 3 is 9. 4 plus 1 is 5. And hey, lo and behold, we get the same thing that we got when we did this mess. And it may not look like a big payoff when you're actually using numbers. It's like, and honestly, it looks like we did about the same amount of work with this way and with this way. But when it comes to actual polynomials, this way right here is going to be a ton easier to deal with than to try to go through all this where you find a common denominator, put them together to get this, and then do your divide and blah, 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 blah. It's way easier to just think about this as kill every fraction. Or you start off with a fraction of fractions. We want to kill every denominator. And so that's what we're going to be working on today. So, does this make sense?
I think so.
Okay, one of the principles that we're using here, and you can't just do this willy-nilly with, like for instance, if I just have OA over B, just by itself, I can't say, oh, I'll kill the denominator by multiplying by B. Now I have A. Well, no, like that's not what we're talking about. This is only in the case where you have fractions inside of fractions, where you have something, oh, like this. How about 1 over y plus x? When you have something like this, it's like if these were just regular old polynomials, if this were just, say, 1 plus x on top and like a y plus 1 on the bottom, I would know what to deal with. But what my mind sees immediately is, uh-oh, I have fractions inside of a bigger fraction. And I think, man, it would be really nice if I could get rid of this guy right here and this guy right here. If they were not down there in those denominators, I would know what to do because I dealt with polynomials divided by polynomials. But now when you have fractions inside of fractions, it's like, uh-oh, that's no good. So what we do is we take advantage of this fact that we have a larger fraction. That is, and this is going to be step 1 in every one of these that you do. After you've written this down, step 1, trust me on this, write parentheses around the numerator and the denominator. And then from there, we're just gonna kill denominators. Looking at the top, what's in the denominator on the top half of that?
X.
X. How do we kill an X in the denominator? What's the only thing we could multiply by that would kill that X?
X.
X, right? Like, and this, it's, don't make this harder on yourself than it needs to be. It's like the only way to get that out of the denominator is to multiply by it, right? And so I'm thinking, well, okay, then if I multiplied this number by X, then it would kill that denominator. Yes, we pick up an additional X over here because this is why I said to use parentheses, because we're going to have to distribute it into there. And we don't want to forget about that. But now I'm taking advantage of the fact that we have this right here. And as long as whenever I write an X on the top, I write an X on the bottom, I haven't changed anything. Right? It's the same principle as when I had 1/3 and I said, well, it would be nice if this denominator were a 12. And so if I multiply the bottom by 4, it'll give me a 12. But I got to do the same to the top. I got to multiply it by the same number. And indeed, yes, that gives you 4 12ths. Oops, not 4 13ths, which is the same as 1/3. And so that's the principle we're using here is like, I need to kill that X. So if I multiply by X, then I'm good to go. But I can't just do that willy-nilly. I got to account for him on the bottom in the same way that we got to do this right here. Does that make sense?
Uh-huh.
Okay, so now I'm looking at this and I'm thinking, okay, there were 2 problem spots. There was that X right there, and now there's one more denominator I need to get rid of. What's the only thing in the world I could multiply this thing by to kill that denominator?
Y.
Y. And so I'm going to say, okay, if I have a Y right here, in other words, if I multiply by the number X, Y, well, I can't just do that. I got to put them somewhere else in order to balance everything out so that I haven't changed the overall fraction. And so I got to put them on the top. So now, okay, we're starting with the thing that we were given, right? 1 plus 1 over X, all divided by 1 over Y plus X. And then I've multiplied by 1, right? X times Y divided by X times Y is still 1. And so I haven't changed that overall fraction. It's still exactly the same fraction. Now, right? I mean, this is the same thing as if you had like X plus 1 times 5. You would have to multiply that 5 into each one of these things to give you 5x plus 5. We're using that same principle here. And this is why I'm really adamant about writing your parentheses here when you first begin these problems, because it will remind you, oh yeah, no, I must distribute this thing. And so the X plus Y jumps over and hits the 1. That's an easy one. I'm not even going to write that out. That's just X plus Y, I mean, X times Y. Plus, okay, the X times Y ends up in the numerator like that, and I have an X left over like that. Okay, so did I do that right? Did I distribute that XY into each one of these terms here
Yes.
correctly? Yeah, I think I did. Now, okay, the X times Y jumps over and it should go into the numerator. This is like by design. This is what we're doing. This is what we want to happen. Should leave me a Y in the denominator for a second. Then he's got to jump in here. And what do I get? What is at, how would I write this? This would be plus what?
X squared Y.
X squared Y. Good. Excellent. X squared Y. Okay. Now let's do our cancellations. And what I'm about to get to a point where I'm not even going to take this step right here. I'm going to do my cancellations like as I write it out. Why? Well, the whole reason, like we knew what was happening, right? The only reason X is in there is because we knew that, like, we chose that specific X so that When it goes over, it's the thing that cancels this guy right here. That's the point of it, right? And if you're keeping the larger picture in mind, it won't be long before we could skip this step where we write everything out, and we'll just write it in its already simplified form. Like for instance, the only reason that y is there is to kill that y. That's why I wrote him there in the first place, because I knew that that y needed to die. And yes, that's what happens now when I have my y over y. But so then finally, let's see what we have. We have x, y plus y. In the denominator, we have just an x plus x squared y. And I would probably just jump straight to here because, again, I know why I wrote that x there. The only reason he's in there is to kill that x. And so I know that when he jumps over there, I get my x plus y. When he jumps over into the second thing, the x's cancel, and all I'm left with is a y, just like that. When this guy jumps over there, the only reason the y was there in the first place was to kill that y. And so I'm just thinking, okay, he jumps over, the y is gone. The only thing that's left is an x, and that's all I write. And then I look and I'm like, oh, there's no cancellations. The x's come together to give me an x squared y. I think we're almost done. In fact, I think we could factor something out. What can I factor out at the top?
An x.
From the top one?
Oh, wait, from the top one?
Mm-hmm.
A y.
Y. One y could come out, leaving me what?
X plus 1.
X plus 1. There we go. And what about the denominator? What do we have?
You can take an x out.
Take the x out. There we go. And what's left over?
X plus 1. Or 1 plus x.
1 plus, yeah.
Y. X,
Oh,
y.
good. Yeah. 1x, yes. 1 plus x, y. Yes. Okay, there we go. There we go. Yes. Thank you. And yeah, and so like, I mean, technically, yeah, we're done here because nothing here cancels, but we're in the habit now of factoring everything out as far as it goes. And when I see this, it's like, oh, there's a y in there. There's a y in there. I better pull them out. Oh, we have multiple x's. Yeah, let's go ahead and pull the x out. And so what we just found. Okay, now this is something we've seen before, right? And like if I were to ask something like, well, I'm not going to ask something like that yet. But this is the type of thing we've been dealing with. And now we're in the realm of stuff that we've seen before. We went from something with fractions inside of fractions, and yikes, I honestly don't know how to deal with that. But I do know how to deal with something like this. And this is how we get from there to there. And the way I think about it is it's the game where we kill denominators. Just kill denominators. That's all we're trying to do. So is everything thus far made sense?
Yeah.
Okay. So let's do some examples from the homework. And, ooh, that's a good one. Okay. I definitely wanted to go over those. Okay, let's do that first. Okay, so. This is all going to be from page 258. And this is number, I wanted to do 12. This is, oops, no, that's not right. It's 1 over x. Minus 1 over y. All over. Whew. Squared minus 1 squared. Over xy. Okay. I didn't write it down on the board, but I said it. Let's see if you're paying attention. What's the very first thing I do?
Parentheses.
Parentheses, excellent. Yes, so I'm going to put parentheses over the top thing. Parentheses around the bottom thing. Okay. Now I'm going to start thinking, okay, I have a fraction that has fractions inside of it. Wow. So the name of the game is kill denominators. We are going to kill every denominator. And so, okay, that means I'm going to go ahead and think, all right, I'm going to have a number over itself because I can't change this fraction. It needs to stay the same. So I need whatever I write on the top, I have to write on the bottom and vice versa. And so how do I kill that one?
Multiply by x.
Okay, so it's going to have an x. How about that one? Oh, oops, look what I didn't do. I didn't put it in the bottom. Whatever I do to the top, I gotta do to the bottom. Okay, so now we're still consistent. I have an x on the top, x on the bottom. I have not changed anything. What about, how do I kill that guy?
Y.
Y, okay. Kind of similar to what we did before. Whatever I do on the top, I have to do on the bottom. Okay, now I have a fraction on the bottom. Do I need to do anything more to kill that one?
No.
No, we're done. And this is kind of like in the earlier thing when I was like, well, we had already had something like this. We had been putting stuff together, and it's like we had a 2 and a 2, and so we had a 2 and a 2. And then it's like, well, I needed a 3 to kill that guy, so I put a 3 there. And then it's like, well, hold up. You don't need to keep going and say, oh, I need to kill that 12 by saying, okay, well, now I need to kill it with a 12. And so, well, no, because that's already 12. It's kind of like the same thing that's happened. And you'll see this in a lot of these, that as you start building up the number that you need in order to kill these guys, well, it might just give you exactly what you need. You might be off by like 1 or something. Like there might be, say, a 5 in here or something like that. In which case you'd say, oh, it's almost the same thing. I just need one more thing. I need a 5 in order to kill that guy finally. And then I put a 5 up here. That's not the case here. Here, we don't need to go above and beyond. As I like to say, we don't need to use a cannonball to kill a housefly. This housefly is dead. This denominator is dead with that guy. And so, now I could be explicit about this, but let's just see, if you could see this in your mind's eye, what we're doing here. I'm not going to write it out because I know what's happening. I'm taking this number, xy, and I'm distributing it over right here. So I can imagine that this number that I'm looking at right here is just directly above that x. And I could say what cancels out?
The x.
The x. And what's left over?
Y.
Just the y. And so I'm just going to write a y right there. And really what's going on in my brain is something like this. It's like, I know I'm going to have a minus sign. I'm going to have some term on this side of it. I'm going to have another term on this side of it. And so now this guy jumps over and hits that guy. We have this guy in the numerator, that guy in the denominator. What cancels out and what is left over?
Y cancels, x is left.
Y cancels. X is the only thing left over, and so I could just jump right to that. That's nice. This guy should be easy. I mean, we're not even like, if you, the whole reason that we didn't need to do anything is because we noticed, oh, hey, that's just going to kill that. I don't need to worry about it. In fact, I could just cancel them both right there. What's left in the denominator?
X squared minus y squared.
X squared minus y squared. Are we done?
No.
No. What do we need to do?
Factor.
Yeah. And what, you tell me what to write. What do I have in the numerator?
Y minus x.
Y minus x. And what is in the denominator?
Well, you have the 2 parentheses.
Uh-huh.
And then you have X plus Y and, well, wait a second. Yeah, X minus Y.
and X minus Y. So we can't pull anything out.
Um, um, mm,
Almost, right? We almost could if that were, if we had flipped those around. Can we flip that around?
well, I think we can
And what do we
just
have?
take out the negative.
Yeah, it's exactly. And that's what I would do. I would start right there. I personally like to have my X's first. And so I'm going to leave these guys this way. We could have done the bottom. We could have flipped the bottom if we wanted to turn that into a Y minus X. But whatever, we chose one, we're going to roll with it. So what do I need to write on the top to make all this consistent?
We'll take out the negative.
Yeah.
And then you have Y, X plus Y. Or no, X minus Y.
X minus Y.
Sorry.
Now I'm going to double, and yeah, good. And I'm going to double check that now, because now I factored something out, right? And so I just want to double check. When the negative comes in, that gives me a negative X plus Y. That's the same thing as negative X plus Y. So I feel good about I feel good about that. So now I'm going to go ahead and cancel. I have an X minus Y on top, X minus Y on the bottom, and I like to write this as a negative 1 over. I guess the only thing that's left is X plus Y right there. And there we go. That is what we're doing. Do you feel comfortable about jumping directly from here to here?
Oh, yes.
Like where I didn't have to go through writing xy over x minus xy over y. And as these start to get more complicated, it's going to be way easier to just do it that way. Like, okay, and this is a lot of students can't do this. Like, you know, when I say, imagine what would happen if you did this, you know, and that's what I'm saying here is like, imagine what it would look like if you did have that over there. And then we could just see, oh, I could pretend that I have an XY over an X and I could see which ones cancel. Anything that would be left would be that Y. It sounds like you feel comfortable with that, which is good. Some people cannot visualize letters jumping around or whatever. And so, okay. Okay, so that was number 12. Another type that you're going to see is number 14. I'm sorry, I erased it without asking. Tough, keep up. All right, number 14. Number 14 is y to the minus 3 plus y. Yeah, plus y. And then y to the minus 2 plus 1.
Great.
Okay. So what do you want to do first?
Probably parentheses.
I like that. I like that a lot. I'm going to start with parentheses too. Okay. Almost there. The only thing is, another thing I hate is negative exponents, because in my head, it doesn't mean anything, right? Like, it doesn't have a physical significance in my head. So how could we rewrite this without negative exponents?
You'd write okay, sorry. Right.
Okay.
Okay.
You'd have y.
Okay. Max.
Okay, buddy.
Max.
Here. There you go. So a negative exponent means take me to the other side of a divide sign and flip my sign. That is what that thing means right there. That's a fancy way of saying that. Just like in your previous homework, when you had something like this, you had 4 y minus 1, 2y minus 5 to the negative 1. That negative 1 means put me in the denominator, right? And so we said, okay, that's the same thing as saying 4y minus 1, and then put me in the denominator, and then make my power the opposite of what it is. And so we wrote it like that. If it were to the negative, let's say the negative 7th power, that would mean put me in the denominator and make my power positive. So that's all that means. So how do I rewrite the numerator here without negative exponents?
1 over y to the 3rd plus y.
Did you say 1 over y to the 3rd? I couldn't hear you over yelling.
Yes.
You said 1 over y to the 3rd. You are correct. 1 over y to the 3rd. Then what?
Plus y over 1 over y to the 2nd plus 1.
There we go. There we go. Okay. So again, now this is interesting. I took a problem I haven't seen before and turned it into a problem that I've just started seeing. But then I'm going to turn that into a problem I've seen before. Okay, so we've been doing the numerator first, so let's do the numerator first. What do I need to multiply this guy by in order to kill that denominator right there?
Y to the 3rd.
Okay, so I need a y to the 3rd. Whatever I do to the top, I have to do to the bottom. Okay, now, are we done?
No. Wait. Yeah.
Yeah, like I mean, we could if you wanted to, you could say, well, I need to kill that y squared, so I'm going to go ahead and multiply by a y squared as well. But this would be killing a housefly with a cannonball, because like that 3 is going to do it. You know, it's as though we had 1/2 and we were already going to multiply it by 4. That 4 is going to do it. But then you don't need to go ahead and add in another 2, because the 4 is sufficient to kill the 2. In the same way that this y to the 3rd is sufficient to kill that y squared. You're going to be left with some stuff. You're going to have some stuff left over, but that's okay. We don't want to have to go above and beyond. And so when I ask, are we done? Yeah, we're done, because that y to the 3rd will do more than the job to kill that guy. So let's take another step. What happens in the numerator? What do we get?
You get 1.
Right? Because, and let's keep this in mind, the whole reason we chose that number in the first place was to kill that guy. And so when he jumps over, he kills that guy. The only thing that's left is whatever's in the numerator. That numerator is just 1, so I'm going to put a 1. Okay, then what?
You have y to the 4th.
Y to the 4th. Go y to the 4th. All right, now what happens?
Y to the 3rd over y to the 2nd is just y.
Just 1 y left over. And honestly, like what I see is I have 3 y's, right? Y times y times y, over 2y's, y times y. And so I have 3y's over 2y's, 2 of them die, 1 of them stays up top. And we're left with that. So then what? How do I finish off my denominator?
Plus y to the third.
Plus y to the third. There we go. Are we completely factored?
No,
Okay, what do I need to do?
you can take a y out
I can
at
take
the bottom.
y out. What am I left with?
Y, and then 1 plus y squared.
1 plus y squared. Oh, it's a sock! Sock! Good job, Peter. Now, are we done?
No. No. No, I don't think so.
You don't think so? I think we are, personally. The thing is, we have squares, right? Because I'm looking at that and I'm thinking, yeah, that's a square. That's a square in disguise. That 1 is 1 squared, but it's
Right. Oh,
sum of squares cannot factor.
right.
Not without imaginary numbers, which
Right.
we're not going to do. So ditto up here, right?
Okay.
1 is 1 squared squared. Y to the 4th is y squared squared. So we have a sum of squares, but we're done. Can't do anything with the sum of squares. If these were minuses, okay, which would have happened if this was a minus and that was a minus, then we would not be done. We would have to factor these guys out. And then we would have to unfoil the top, or well, I guess it would be 1 plus y squared, 1 minus y squared. Oh, 1 minus y squared, actually. And we wouldn't need to factor that guy out because we would have that right there. And we could say, yep, okay, that guy cancels. And then we would just have that. But that's not the case. In this case, we do have pluses. The sums of squares we cannot do anything with. Sums of cubes we can, but we can't do anything with sums of squares. So in this case, we are done right there. That should be the answer. Okay, so that's some other stuff you're gonna see. A couple more I wanted to do. Let's do, ooh, that one's ugly, but we're gonna do it. 18. $18 is y over x minus y plus y over y all over x minus y x over x plus y over x plus y. Yikes. Okay, step 1. What do we do? Not using our brains here. I'll wait for you.
Parentheses.
Parentheses. So I don't want to forget that I have to distribute whatever it is into every single term there. And so, okay. What do I need to, let's just start in the top left-hand side. What do I need to kill that first denominator?
Multiply it by y, x minus y.
Yep, that guy is x minus y. The only way to kill him is to multiply by him. And so x minus y, and I'm going to write these with parentheses. It will be very helpful. And so whatever I do to the top, I got to do to the bottom. I'm also going to go x minus y right here. Okay, are we done with the top? What about that other denominator?
I have to multiply it by y.
Got to do y. So I'm going to do y on the top, y on the bottom. Okay. Now I'm going to look at the bottom, and I'm not going to go overkill here, right? Just like last time, we had the y squared, and we were already multiplying by a y cubed, which would kill it. But in this case, we're not in that case anymore. We have not killed him yet. What do I need to do to kill him?
I'm sorry. Multiply by x.
Got to use the x. There's no way around it. Got to do x, and so we do that on the top and the bottom. And what about the last one?
X plus y.
Yeah, and we haven't done it yet, right? And every step along the way, I'm checking to make sure I'm not going overboard here. And I can see that, yeah, I don't have an x plus y here yet. So I got to add him in. So I'm going to say, okay, x plus y. And so I got to do it on the top too. You can see these do get ugly, and I'm sorry, but that's life. So, okay, on the top, I'm just going to go ahead and imagine that all of these things jumped over, and I'm going to get one thing that cancels.
Y. You get y.
That guy kills that guy, and I'm left with this.
Oh, yeah. Oh, gosh.
And so that gets multiplied by y. And so that all together, right, if that guy right there jumped over, the only thing that would cancel would be that x minus y, and I would pick up an additional y to give me a total of y squared x plus y. Do you concur? Did I do that correctly?
I think so.
I think so. I just want to make sure, right? If that number were sitting on top of this fraction, that would cancel with the first thing. We would pick up an additional y, so we would have a y times all of this stuff that's left. That would be y times y is y squared. The x comes along for the ride. The x plus y comes along for the ride. Okay. Now, plus, we do the same thing over here. What cancels when that guy jumps into that fraction?
The y.
The y's cancel, and who's left over?
X minus y times x plus y squared.
Yes, good. That's how I would write it. That's how I would write it. And because I just visually saw that cancels that, so I'm going to be left with all those guys. And so I just started writing them down and said, oh yeah, he's going to come along for the ride too. And so he's already there, and so we're going to have to square him. Okay. Now the bottom.
Oh.
What happens with the bottom?
X minus y squared.
Yeah, good.
Y.
X squared.
X y. And then
The what now?
x. Then you have the y,
And the y. Okay.
and then x plus y.
And the x plus y. Yep, exactly. X plus y. Finally, what do we have in the last bit?
X minus y.
X minus
Y squared x.
squared x, and then that guy has killed that guy, and we are done. Now, this is really ugly. We're gonna waste a lot of time, but now at the very least, we're back into the realm of problems we've seen before. This was a nightmare. I have fractions inside of fractions. This is also a nightmare, a different kind of nightmare. It's a nightmare that we've been working on. And so have fun with stuff like this in your homework. But at least we're at a point now where you could deal with this. One cool thing to notice though is you can factor some stuff out of here. Like for instance, there's an x in here and there's an x in here. There's an x plus y and an x plus y. And so you could start factoring some stuff out to make things a little bit easier to deal with. So again, have a lot of fun with these types of problems. So we're going to move on. Another type of thing you're going to see is
real quick, I do need to go by 12.
By 12. Okay, cool. So yeah, there's not much more to say. The only other thing is you're going to have stuff like 4x minus 5 plus, we'll just call it 1x plus 2 over 1 over, let's go, x squared. It would be a minus 3x minus 10 plus 1 over, say, x minus 5. Now, in this case, if you have something like this, you'll notice, well, this guy could be factored, right? You're going to end up with stuff like this. And of course, that's what you want to do. You want to factor this guy down. And so I could say, well, that right there factors down to, well, it has to be an x and an x. 10, let's try a 2 and a 5. And really, I definitely want to try a 2 and a 5 because, well, looking at the overall problem, 2 and a 5. And so 2 and a 5 needs to be a negative, so one has to be positive, one has to be negative. The minus 3 here, maybe it should be a minus 5. Let's try a plus 2 minus 5. And oh, hey, yeah, lo and behold, that does work. That is how you factor that. And hey, what do you know? It also involves the terms that are in there. So I would just rewrite that guy as x plus 2, x minus 5, like that. And now, in order to kill every denominator, what do I need?
An x minus 5 and an x plus 2.
X minus 5, so that kills that. You said an x plus 2. We got to do them on the top and the bottom. Anything else, or is that going to kill every denominator we see?
That's going to kill every denominator.
That's going to kill every denominator we see. We don't need to go above and beyond, right? That'll do it. Okay, so you'll see stuff like that. I'm not going to assign those. Finally, okay, we have 14 minutes. Okay, here, oh man, one of the challenge problems. Hey, buddy. Hey, buddy. This is one of your challenge problems. And it says simplify this. And in case you can't read that, I'll make this a little bit better. That is a 1 plus 1 over x right there. And you think, what a stupid contrived BS. This is actually, this is an important thing. If you ever take a class in number theory, you will do what's called continued fractions. And this shows up. This is a real thing.
Right.
This is a thing. So it says simplify this. What you should do, what I'm going to recommend that you do, is think about these one bit at a time. Forget about the rest of the problem and first just focus on this guy right here. And we're going to say, okay, if you just gave me that thing right here, 1 plus 1 plus 1 over x, and I wanted to simplify that, we're going to play the same thing. We're going to say, okay, This is the type of thing we're doing where we go like that. What do I need to do to kill the fraction?
Multiply it by x.
Multiply it by x. Whatever I do to the bottom, I've got to do the top. And so now the numerator becomes what?
X.
Just x. Yep. And what is the denominator now?
1 plus 1.
Say again.
1 plus 1.
Wait.
Oh, wait. X over x is just x. Right. Oh, right. X plus 1.
X plus 1. Exactly. Perfect. Okay. So now what we just said is that this is that part right there. And so what you're going to do is say, oh, I've simplified that part. So in fact, I'm just going to go ahead and substitute it back in. Of course, you won't be doing this on a whiteboard. You will have to write this over again. And we'll have an x over x plus 1. And now, oh, hey, look at that. This is now a fraction that we could simplify. We'll do one more. And we'll say, okay, well, that is just 1 over 1 plus some stuff. I'm only seeing one denominator here. How do I kill that only denominator that I see?
Multiply by x plus 1.
Multiply that by x plus 1. So I need to do that also to the top. And that leaves me with, what do I have on the top?
X plus 1.
Yep. And what do I have on the bottom?
X plus 1 over 1 plus 1.
X plus 1 from that first bit plus what?
1. No, wait. X.
Just
Right.
x. Yep, just x. And now I guess we could write this in a couple different ways. I would suggest that we just go ahead and write them in descending order and call that 2x plus 1. That's probably going to be the easiest way of doing this. But now we're halfway there. Have fun. But this now is that right there, right? That's what we just said. And so we can replace this thing right here, and now we have our final fraction that we'll do and stuff like that. Yeah, so that's the idea with that one. Did I get the right? I did get the right number of those. 27. This is gonna be, it's tough. This is another challenge problem. But I just want to remind you here, if we had something like this, f of x is equal to, say, x plus 1. And I said to compute f of x, what we've talked about a bunch of times is we say, well, this right here means the same thing as this right here. So this is the same thing as f of x plus 1. From there, I could say, oh, wait a minute. F of anything is just says take that thing and add 1. And so I just say, well, whatever goes into it plus 1. If it were more complicated, if it were like x squared plus 1, I would have whatever squared plus 1. If it were 1 over that, right, I'm just thinking, I'm not going to go too much into this, but in this case, this says, oh, x plus 1 is the thing I'm plugging into that function. So I plug in x plus 1, and I guess I could write that as x plus 2. And so I would have f of x equals x plus 2. And so then, and this is the key here, if my problem were f of f of x, and I said compute that, we'd say, well, wait a second, we've just computed this. We know what f of x is. And so we could just replace that right there. We'd say that symbol right here means the same thing as this right here. So I'm just going to replace it. And so f of that, and then we just plug that back into our original formula right there. Only you've probably guessed this is going to involve fractions of polynomials. And that should be enough. I mean, just really, if this thing were instead in something like that, right? You're just going to take the shape of whatever it is, and whatever shows up in here, you just take and replace into there instead. And it'll be fractions inside of fractions, and then you'll want to simplify them, and so on and so forth. Okay, homework. I believe it was 35. You said no, it was 43. Which also involves composition of functions. And this was from page 254 from last time. Finish number 43. And then for this one, this is chapter 6, section 3 from page 258. And we're doing number 1 through 19 odd. And then do not hesitate to ask me for help with any of these. They get ugly. But yeah, it's not that much. It's 10, 11, 12, 13 problems. Then plus the one from last time.